The power of a product property. This is Chapter 1, Lesson 4, Part 1. The power of a product property is the opposite of what you did with the product of a power. The power of a product rule states that if you are finding the product of two different bases, again, this is when we are dealing with different bases that have the same exponent, the exponent can be distributed to each base. So for example, if we have g times h and they're both being raised to the third power, it would be expanded as g times itself 3 times plus h times itself 3 times, which could be simplified into g to the third plus h to the third. We can also work this in the opposite direction. If you had p to the fifth times, this should have been multiplication, g to the third times h to the third. If we had p to the fifth times q to the fifth, we could separate that out and have p times q all raised to the fifth power. If the bases are actual numbers, you can then multiply them inside the parentheses to simplify. So here I'm going to show you some examples of where we're actually applying the power of a product rule. So you see in part A we have 5 squared times 2 squared. The bases are different, but because the exponents are the same, we're able to use that power of a product property. I can put that 5 and the 2 both inside the parentheses here. And because I can do that and have them both raised to the second power, then I could simplify that even more, which is where I get this 10 squared. And if you were asked to evaluate that, it'd be a little bit easier to know that this is 100 than doing these as two separate expressions. Part B, we're dealing with some negative decimals here. Negative 1 and 2 tenths cubed times negative 2 and 5 tenths cubed. Again, the bases are different, but because the exponents are the same, I can apply this and put both of those decimals inside my parentheses and raise them to the third power. And after doing the multiplication, you would see that you could simply get 3 to the third power. Again, a lot easier to figure out that 3 to the third power is 27 versus doing the repeated multiplication with those decimals. The same works here for fractions. 1/2 to the fourth power times 4/5 to the fourth power. Because our exponents are both 4, I can multiply our fractions first. 1/2 times 4/5, which would equal 4 tenths to the fourth power, and they simplified 4 tenths down to 2/5 to the fourth power. So let's do some practice here, applying that power of a product rule. Here we have 10 to the third times 12 to the third. So I'm going to apply the power of a product property because both exponents are the same, even though the bases are different. So I'm going to put both bases, 10 times 12 here in parentheses, and raise it all to the third power. And then to complete my simplification, I do my multiplication. 10 times 12 is 120 to the third power. Here in number 2, 4.5 to the second power and 8.2 to the second power. Because they're both to the second power, I can use the power of a product property. Inside my parentheses, I'll write both of my decimals, 4.5 times 8.2 to the second power. And when I do my multiplication, I wind up with 36.9 to the second power. It's a little bit more practice here where we have negative 1/3 to the fifth power times negative 3 to the fifth power. It doesn't matter that one's a fraction and one's a whole number. Because they still have the same exponent, we can still apply the power of a product property. And I'll have negative 1/3 times negative 3 all to the fifth power. If you're struggling with that multiplying fractions, remember, I can simply add, I can do negative 1/3 times negative 3 over 1. Any whole number, you can just make it a fraction by putting it over 1. So that means negative 1 times negative 3 is a positive 3 over 3, which simplifies all the way down to 1. So after our multiplication, we are left with 1 raised to the 5th power. Here we have some more practice applying the power of a product rule. We're incorporating variables and coefficients, and there's a couple extra steps in here. Just our first example, we have x to the 6 times y to the 6. Same thing, different bases, same exponent. So you are going to multiply the bases together. Because they're variables, all you do when you multiply is keep them as x, y, because we don't know the values. We can't combine them. In part B, we have 7a and 8b, both raised to the 3rd power. When you have the coefficients and the variables, we are actually able to multiply the coefficients together. So here you see that 7 and the 8 in front of our variables are multiplied together to get that 56. And then again, the variables just are pushed up next to each other, and you keep your exponent of 3. Now part C, we get even a little bit more complicated with the fractions and the whole numbers with the variables. So negative 1/2 p to the 5th power times 10p squared to the 5th power. So first things first, let's put those all together, 1/2 p times 10p squared together first. So we're going to regroup the numbers and then our unknowns. So the numbers you have in this first expression is negative 1/2 times 10. Those are the two numbers. And then the unknown, since that p was in the denominator, it becomes 1 over p times p squared. So you do the multiplication here. Negative 1/2 times 10 becomes negative 5. And then 1p times p squared becomes p squared over p. Before we can go any further and do any more simplification, you're going to actually apply that quotient of powers property here to get that p squared divided by p into just one term. So you're going to do p squared minus 1, and that's just p to the 1st power. So now we have negative 5p to the 5th power. Again, I know that one's a little difficult. You won't have to do a whole bunch where they require the mixing of fractions and whole numbers like that. But in case you do run into a challenge, just follow the step-by-step process.